Alright, let's go over example 2. So we have x squared minus 3x minus 10. We're going to check for a GCF before we do anything. So there's no GCF. A, B, and C. So A is 1. We're going to set up our chart. Always off to the side. You don't want to work under the problem because you need that space for later. So ACB, CAB, however you want to do it. A times C would be 1 times negative 10, which is negative 10, and B is negative 3. So I need two numbers that multiply to negative 10 and add to negative 3, which are negative 5 and positive 2. And I always just kind of put a check mark to make sure that they add correctly. Once I have that pair, some of you guys, it might take a few tries, but as soon as you have that pair, you split the middle term. So x squared stays there. This becomes minus 5x and plus 2x. It doesn't matter which one goes first. As long as the 5 is negative and the 2 is positive, you can write it the other way. And then minus 10. Then you grab your groupings. That's x times x minus 5. Group plus 2 times x minus 5. So my answer would be x plus 2 times x minus 5. And you can have those swapped around as long as, again, that 2 is positive and the 5 is negative. Let's do this a couple more times. And then some of you are noticing a pattern, and I'll talk about that pattern. And if you don't notice it, that's totally fine. Let's do another one. Example 3. This time we have 2x squared plus 4x minus 48. If you want to try this one, you can pause the video. If you're a little nervous because the coefficient is a 2, you can just watch me, and then I'll give you another one to do on your own. So for this one, step 0 says check for a GCF. We've got 2, 4, and 48. They're all even, so we definitely have a GCF of 2. We're going to take that out, and we're going to rewrite the problem. X squared plus 2x now minus 24. So you rewrite it. The GCF you pulled out does not go away. We're just going to hang on to it till we get down to the end, until after our grouping and we have our final answer. The final answer will have that GCF in it. Alright, so for now we're just going to focus on the trinomial of leftovers. The leading coefficient is 1, so that's A, B, and C with your leftovers. We're going to set up our chart. 1 times negative 24 is negative 24. I don't want you to think that it's just C. Some students get in a really bad habit of like, it's just C. The only reason it looks like it's just C is because the leading coefficient is 1. If that's something different, which we'll do a couple examples of, it's not just the C term. So it's always A times C and then B. So I need two numbers that multiply to negative 24 and add to positive 2, which would be positive 6 and negative 4. You'll get better and quicker at guessing those pairs if you're not so good at that yet. So now we're going to, again, just working with the leftovers, split the middle term. Doesn't matter which one goes first. And then we're going to group x times x plus 6. Take out the minus 4. That should also leave x plus 6. So my final answer is going to have the 2 and then the binomials. So I always draw an arrow and write it again so that I don't forget. Your final answer includes that GCF you took out from the beginning. Your online exam will not count it correct if you do not have that leading GCF that you took out, if you took one out. Alright, I want to give you one of these to try if you did not try example 3 on your own. Example 4, 3x squared minus 3x minus 18. Pause the video, try it on your own, and then play it back and see how you did. Alright, so for this one, again, we're scanning for a GCF. You should start to see these right away. 3, 3, and 18 have a GCF of 3. That leaves me with x squared minus x minus 6. I'm going to take that 3 I took out and rewrite it down here so I don't forget about it. I'm going to work the rest of the problem with the leftovers. So I have A, B, and C. A is positive 1, B is negative 1, C is negative 6. So I set up my chart. 1 times negative 6 is negative 6. Again, it's not just C, it's both. It just happens to be a 1. And then B is negative 1. So I need two numbers that multiply to negative 6 and add to negative 1, which should be negative 3 and positive 2. I'm going to split my middle terms. This is x squared minus 3x plus 2x. So I'm using those numbers to split. And then minus 6. Doesn't matter which one you put first or second as long as the signs are correct. Now we're going to group. So that's x times x minus 3. Take out a positive 2. That'll leave x minus 3 from the second group. So my final answer has the 3 from the beginning out front, then x plus 2, and then x minus 3. Now some of you might be noticing, and your instructors might have shown you this, which is totally fine, that when the leading coefficient is 1, so in all of these examples A is 1, A is 1, A is 1. When A is 1 and AC looks like it's just C, even though it's not, it looks like it's just C, you might have noticed that the two numbers we're getting from our chart, negative 5 and 2, exactly show up in our answer. And that's okay to observe. And that only happens if the leading coefficient is 1. So you'll notice positive 6, negative 4 are the numbers that show up in our binomials. So some teachers teach a shortcut to go straight from the two numbers you've thought of to the binomials and skip these two steps. There's nothing wrong with that. However, if you get a little overzealous with that, you'll start skipping steps all the time. And this only works, going straight from here to here, only works when A is 1, when that leading coefficient after you've taken out GCF is 1. Then you can go from here to here. But I don't want you to make habits of skipping steps if later on when you can't skip them, you'll forget. So I'm very much about consistency. This is the full process. It works every time, no matter how complicated the problems are. So I do not encourage you to start learning to skip steps and then forget to go back and do the full process. So let's look at a few where the A is not 1, where it actually is a little bit more involved. And you just keep going on example pages. I know these take up some space, so you just make EX pages as needed. And make sure you fully understand what's going on here. Watch this video as many times as you need until you really understand what we're doing. I don't want any guesswork on this, and I don't want you to kind of understand it and just get lucky. I really want you to fully understand what we're doing here. So example 5, let's see. Here's a good one. Let's do 4y squared plus 12y plus 9. 4y squared plus 12y plus 9. We're looking for a GCF between 4, 12, and 9. It kind of looks like there's a GCF. There's a GCF between 4 and 12. There's a GCF between 12 and 9. But there is not a GCF between all three. 2 is not a GCF. 3 is not a GCF. So there's no GCF in here. And take a second and double check. If there is a GCF, take it out. But sometimes there's just not. So this time A is 4, B is 12, and C is 9. So I'm going to make my table. You can call it the CAB table if that helps. CAAC, doesn't matter. 4 times 9 is 36. So remember, it's both values multiplied together. B is 12. So I need two numbers that multiply to 36 and add to 12. That's kind of easy, 6 and 6. So I'm going to split 4y squared plus 6y plus 6y plus 9. So I'm splitting the middle term, leaving the first and the last the same. That makes 4 terms, so I will group. Take out a 2y, that leaves 2y plus 3. Take out a positive 3, that leaves 2y plus 3. That gives me 2y plus 3 times 2y plus 3. It's actually the same thing twice. That does not happen very often. Sometimes you'll get the same binomial twice. You didn't do anything wrong. It's called a perfect square trinomial, which we'll talk about later. But if you get the exact same binomial twice, the shorter way to write it is 2y plus 3 to the second power on the outside. So if you get the exact same binomial twice, you write it a single time squared, which again does not happen very often. This one just so happened to work out that way. Alright, so if you notice, when a is not 1, a is 4 this time, 6 and 6 do not appear in our answer, whereas they did before. So again, that shortcut only works if a is 1, and I don't want you to get in the habit of using it and then forget the full process. So here's another one to try, example 6. Let's do 8x squared minus 18x plus 9. Pause the video, try it for yourself, then play the video back to watch the solution. So on this one again, we're scanning for a GCF. It kind of looks like there's a GCF. Between 8 and 18, there's a GCF. Between 18 and 9, there's a GCF. But between all three, no GCF. So this is A, this is B, this is C. So A, C, B in our table. 8 times 9 is 72. B is negative 18. I need two things that multiply to 72 and add to negative 18. You might not know that in your head. Let me show you a way to do this in the calculator. If you have a graphing calculator, let me turn the light on so you can really see it. Maybe. There we go. Ooh, too bright. Alright, so 72 has a lot of multiples. So many. And we don't know which ones are going to add to negative 18. Maybe you know, but if you don't, let me show you what you can do. You go to y equals, which is the top left button of your calculator. You type in the number you're trying to get to, 72. You divide, which is the division key, by x. Now x is right next to alpha, which is right below the second key. There's an x, a t, this thing that looks like an O, and an n. You're going to just push that button and an x should appear. So it's the number you're trying to get to divided by, and then the x button, which has a whole bunch of other letters which we're not going to get into. Once you type it into y equals, you push second. You should see a little up arrow. And then above the word graph is the word table, and you'll push that. What this is going to do is give you the list of numbers that multiply to 72. 1 times 72, 2 times 36, 3 times 24, 4 times 18. All of these things multiply to 72. We need negative numbers. We know that if we need a positive product and a negative sum, we need negative numbers. So if you push the up arrow, you'll get into the negatives. So you're trying to find two negative numbers that add to negative 18. So if you look, negative 6 and negative 12, we know multiply to 72 because the way we set it up. And in our heads, we see that they add to negative 18. So if you ever have trouble with the pairs, you go to y equals, you type in the number you're trying to get to, divide by x, x is here, and then second graph, you get pairs of numbers. You can go up and down as much as you need to find the magic pair that works. All right. I'm going to turn that light back off. So we're going to leave that one the same. 8x squared minus, we're going to split that, 6x minus 12x, and then plus 9. We're going to group. So looking at these two, that's a 2x. That leaves me with 4x minus 3. Looking at these two, I'm going to take out a negative 3. That's also going to leave me 4x minus 3. So my answer would be 2x minus 3 times 4x minus 3. Back-to-back binomials, and you can FOIL it to double check. All right, let's keep going. Let's try another one. Example 7. Let's try 6x squared plus 5x minus 6. You can pause the video and try it for yourself, or you can just watch me. So we have A, B, and C. We're going to look for GCF. 6, 5, and 6, there's no GCF. So we're going to set up our table. 6 times negative 6 is negative 36. B is positive 5. Trying to find two numbers that multiply to negative 36 and add to positive 5. That would be, let me think, positive 9 and negative 4. Should do the trick. So we have 6x squared plus 9x minus 4x minus 6. So we're splitting the middle term, leaving that one the same. Then we'll group. It's a 3x. That leaves 2x plus 3. From here, we'll take out a negative 2. That should also leave 2x plus 3. So my final answer should be 3x minus 2 and 2x plus 3. You have to type that in very carefully, especially on your online exam, to make sure you don't get anything mixed around. Alright, let's see. If you're feeling good about this, you can keep watching for more examples or move on. There is one other piece to this that I'll record in a separate video, but I want to do a couple more examples just to make sure we're good. So example 8. Let's do kind of a crazy one for this one. Let's do 12x cubed y minus 22x squared y plus 8xy. That one looks kind of crazy. You can try that one, or you can watch me. You can pause the video if you like, or just follow along. That looks really, really scary right now. That means we need to look for some GCFs. We've got 12, 22, and 8. So we can take out 2. We have x cubed, x squared, and x. So let's take one of those out. And every single term has a y. Let's take that out too. Take out as much of that as you can to clean that up, and it will look much better. That leaves me with 6x squared minus 11x plus 4. So much better to look at. So the 2xy we're just going to hang on to, and we'll put it back on our answer. For our factoring, we're going to focus on the leftovers, a, b, and c. So we have a, c, and b. A times c is 24. B is negative 11. So I need two numbers that multiply to positive 24 and add to negative 11. So that'd be negative 8 and negative 3. So we'll have 6x squared minus 8x minus 3x plus 4. I don't know if the arrows help. Then we'll group. It's going to be 2x times 3x minus 4. Here the only thing we're going to take out is that negative, so we'll take out a negative 1. That'll switch the signs and make it positive 3x minus 4, which is what we need. So our final answer will have 2xy, 2x minus 1, 3x minus 4. So it looks a little crazy, but when it looks crazy like that, just take out a GCF. Alright, I'm going to stop there and record a separate video for the next part.